Good afternoon, everyone. I'm here to introduce our group, the Taxonomy Squad. We're doing a presentation based on matter. I'll now hand you over to Miss Charles, who will give you our first experiment.
Good afternoon, my name is Miss Charles, and I will be demonstrating to you experiment number 1, which is kinetic theories. We're going to look at explaining macroscopic property of solid, liquid, and gases, change of state, expansion of heat, compression of gases, and air pressure. Our title for this experiment is exploring air and air pressure. Our aim is to observe airspace to determine if the pressure of gas increases, changing solid into liquid. The material needed is our syringe. We have some small pieces of chalk, some water, a candle, and matches. Good. Let me first deal with change of state. And when we're looking at change of state, we're looking at expansion of heat at the same time. Everything around us is matter. The ice, the cup of water, everything is matter. First, I'm going to demonstrate using the solid into liquid. First, I compress it and I use the heat from my hands to change this solid into liquid. You can see there, it is changing from solid to liquid with the uses of heat. Now I'm going to demonstrate to you the compression of gas using my syringe. I use some small chunks of chalk and I insert it into the syringe to demonstrate. When you put this part of the syringe into this body, it cannot compress. You can see it cannot compress, right? But if I remove the chalk and I use some water, it is easily compressed. You see there? I use my finger at the top of the nozzle and I try to compress air. It is compressing, but not as easy as the water did. I will also demonstrate air pressure using the candle. This here is to allow the candle to stick on the plate. Then I use my water to throw into the plate. Make sure my glass is dry. Use the glass over the heated candle. The candle will eventually goes out and the vapor of the water will suck the oxygen will suck the water up into the glass with the heat. And you can see there, the water enter into the glass. I can raise it and the heat from the candle causes the glass to stick. And then you see there. Thank you.
Good afternoon, students. My name is Miss Kelman and this is Miss Lewis. Today we will be doing an experiment based on diffusion. Our title is Comparing the Rates of Diffusion Under Temperature. Our aim to observe the process of diffusion. And these are the materials that we will need in this experiment. 1, cups. 2, water, hot and cold. And 3, dye. Let us recap what is diffusion. Diffusion is the movement of particles from a high concentration to a lower concentration until it is equally distributed. We will begin this demonstration by the following steps. First, on the right hand side, we have a glass with cold water. On the left hand side, we have a glass filled with hot water, approximately 80 degrees to 90 degrees hot. We start by putting 2 drops of dye in each glass to see the results. In the hot water, the dye is very well mixed. In the cold water, it takes a longer time to settle. Let me explain what the experiment is telling us. It is telling us that with high temperature, the dye molecule is able to move around very efficiently, causing diffusion. On the other hand, there is a slower diffusion in cold water.
Good afternoon, students. I will be doing experiment 3, osmosis. The title of this experiment is the movement of water molecules from a high concentration to a low concentration. The aim is to observe the process of osmosis. The materials needed are potato, cup, sodium chloride, which is salt, and a plate. So before we go to the experiment, let me go to the topic osmosis. What is osmosis? Osmosis is the movement of water molecules from a high concentration to a low concentration to a semi-permeable membrane. Now, the experiment. The first step in our experiment is we'll pour water, drinking water, into a container. We place 1/2 of the potato into the water. The next potato, we'll place it without any water. Now we'll take our salt and we're going to pour it into the potato. What we'll observe this afternoon is that the water from the container will absorb in the salt solution, and it will absorb faster because there's water on the outer layer of the container, and on this potato there is no water. So let's wait and see.